Welcome to Tuesday Lunch and Learn. I'm James Shore. Every week we choose a software engineering topic, come up with a challenge related to that topic, and then solve it live on stream. This week we're canceling network requests. This is the penultimate episode. This is the next to last episode. So next week will be our final episode. Be sure to stick around at the end for information about that and also what I'm going to be doing next. If you'd like to follow along with today's episode, you can download the code from GitHub, github.com/jamesshore/livestream. Check out this tag right here, 2020-09-22. And of course, your questions and comments are always welcome. Just go ahead and toss them in the chat. I'll take some as we go, and we may have some time at the end for more questions. This is a long episode, but I think we'll be able to get it in just under the wire or maybe a little bit longer. My goal is to be done in about an hour. So let's get right to it. Our topic today is request cancellation. Specifically, what we have is, if you've been watching past episodes, which you can find down here, jamesshore.com/s/LNL for Lunch and Learn. If you've been watching last episodes, you know we've been building this little client server application. It's a command line tool to call a microservice that does route 13 transformations. So you say, you run the command line, you pass in hello, and it gives you URYYB back. Now, a lot of what we've been doing is taking care of error handling, and one of the types of errors that can occur is the server just doesn't respond. And last week, we set that up to time out so that if it didn't respond, we would display an error on screen. Hey, Pellet, welcome. Glad you could join it. Yeah, next week is the final episode for the show, but I do have some other stuff I'm going to be working on, and so I'm not going away, but it will be the last live stream. So anyway, we've got, hey, Uncle Scientist, glad you could make it. So we've got the ability to time out when the server doesn't respond, but we don't actually cancel the request, so the application doesn't exit. And let me show you what I'm talking about. Now, again, if you'd like to follow along, github.com/jamesshore/livestream, check out the tag 2020-09-22, and then you will need to install Node.js because that's what everything's written in, but everything else is vendored into the repo. So you should be able to build the code and test it by running build.sh, and that will lint all the code and will also run all the tests. I'll let that go through. It goes a lot slower on my machine when the streaming software is running for some reason, but it should be much faster for you. So let that go. And then on Windows, of course, you can just run build. If you want to only run it, lint and test the files that have changed, use the build quick option. And then if you would like to have it automatically lint and test code whenever you make changes, then use the watch option. And that will also make a nice little sound when the tests pass or fail. Now, to actually run the code, it is client server, so you need to run the server, which you can do by doing /serve.sh or serve on Windows, along with a port number. That will start the server, and then in another window, you can run the command line code, the command line client, by, again, typing run, the port, and then whatever it is that you want to transform. In this case, hello. And sometimes that will work, but sometimes the server will time out, and you can see that here. And it will wait 5 seconds. It will tell us that it's timed out, but notice that the command line hasn't exited. And that's because the request is still in progress, and Node.js won't exit the process until everything that's in progress has finished. So that is the challenge for us. We need to be able to cancel the requests when they time out. Now, it turns out that doing this is actually not that hard. So we've got all the codes in this sort of mono repo. We've got the microservice in this code, we've got the command line code, and we've got some shared code here. This isn't to be confused with the third-party modules, which are here. Now, in our command line code, all of the conversation, all the communication to the server is handled by HTTP client. And it turns out in Node.js, canceling a request is actually really easy. The way you do it is right up here. This is where we make the request. We've got a bunch of runtime type checking, which you don't need to worry about. And then we return a promise that actually performs the request. And here's the node request right here. That returns a node request object. Now, to cancel this request, all we have to do is type request.destroy, and pass in an error. That's it. That's all it takes to cancel a request. So this is not actually a cancellation challenge. This is actually a design challenge. The question is, how do we get this destroy to happen? How do we either get access to this request, or how do we tell this request that is in process that it needs to destroy the request? So that's the real challenge. And how do we do it cleanly? How do we make it testable? So while you're thinking about that, I want to remind you that this show is made possible by the people who hire me for training and consulting. These are a bunch of above average folks, or I think so, who obviously have the wisdom to bring me on board. The reason people bring me on board is because they have software teams, software organizations that have the capability for a lot of business agility, but actually don't have the technical capacity that people want. So they're not able to deliver software as quickly or as in high quality as the business needs. So that's where I come in. I either do training, I can do that remotely, of course. I also do process design, I do embedded coaching, which I can also do remotely. Particularly as companies grow, there starts to become bottlenecks between teams. As they add more teams, they find that the communication between teams becomes a challenge. Communication between teams becomes a challenge, and that they're gated by particular teams. And solving that is a process problem, it's a social, it's a people problem, and it's also a technical problem. And I bring some expertise in all three of those areas to help out. So if this sounds interesting to you, go ahead and send me an email, jshore@jamesshore.com, or visit me on the web, jamesshore.com. You're also welcome to send me a tweet. Anybody, send me a tweet for any reason. I love hearing from folks. So let's get back to the challenge. We want to cancel our requests, and we want to do so in a way that is well-designed and testable. So how do we do that? Well, typically, when I'm faced with a design problem that is sort of a generic design problem, I will look at other people's solutions, especially something like this where it is a well-known problem, canceling requests. First thing I do is just look and see what other people have written about it. But then I also try to make my own solution, and a great technique for that is programming by intention. Programming by intention, of course, is when you write your code, your high-level code, as if all the low-level code you need is already written, already done. Because what happens is these generic solutions often have a lot of complexity in them because they have to handle every possible scenario. But for our code, we can cut out the stuff that doesn't matter and just solve the problem in front of us. We can cut that Gordian knot by not doing the things that are complicated. So I will, in addition to looking at the generic solutions, also say, well, what about our code makes this easier? And is there a way to come up with a simpler solution? And then once you've looked at both of them, you critique and you choose one. So let's do that. Let's start out by looking at the generic solutions. And if you do some research online about canceling requests, what you'll find is a typical approach called cancellation tokens. And this is widely implemented in .NET, for example, C#. And the way it works is that you instantiate an object called a cancellation token source. Anything that can be canceled takes a cancellation token parameter. So you take your cancellation token source and you ask it for a cancellation token, and you pass that cancellation token into the thing that can be canceled. And then later on, if you want to cancel it, you tell your cancellation token source, please cancel all the cancellation tokens. And then it goes ahead and does that. Let's go ahead and see how that would work. We'll try that out in our code. Now, real quick, the way this code is written, we've got our top-level route 13 command line code. That depends on the route 13 client, which in turn depends on the HTTP client. And let me show you that code here. So again, here's our route 13 client. That depends, our route 13 command line, which depends on a route 13 client, which uses the HTTP client to talk to the server. Now, for our prototyping, I'm just going to do that right here. Let's go ahead and just put another example of what this would look like side by side. Now, I'm not going to try to do this for real. I'm just sort of feeling out, see what it feels like to use this code. So I'm going to say we've got a cancellation source, and we'll make a cancellation token source. And then we would pass a token from that cancellation source into our route13.transform async. So it'd look like that. And then when we want a timeout, we would use our cancellation source. So I'll pass that through to our timeout code, which is down here. And our cancellation source would wait for the clock to finish, for it to time out, and then it would call cancel. So that's what the cancellation token approach looks like. And I think that's pretty clean. I do like that. There are some flaws here though, and I think the biggest flaw in this code is that it's very, enterprise objects. It's just got this sense that you get from a lot of C# and .NET code of, we got a whole bunch of scaffolding sort of hiding behind the scenes. We've got this cancellation token source. We've got cancellation tokens. Somehow the cancellation tokens have to inform the underlying code how to do its work. So it's sort of big and complicated. But, you write that once and it's off to the side. The other thing I don't love about this code is that it's indirect. Cancellation source.cancel is clear, but it operates on cancellation source, and the connection between this cancel and actually canceling route13 client.transform async, it's sort of implicit. Now that's not a problem if you understand how cancellation tokens work, but for people who are unfamiliar with cancellation tokens, it's going to be kind of magical, and I dislike magical code because it's always harder to understand, and the more code that you have to deal with, the more maintenance burden you have, the more bugs you're going to have. So although I think this cancellation token approach is pretty good, I think it could possibly be better. That said, people have put a lot of work into figuring this out. A lot of smart people have worked on it. There may not be a better solution. But let's see what we can come up with. So when you're building your own solution, again, what we've done here is we've looked at the generic solution, but now what I want to do is I want to use programming by intention to make a simpler solution that's specific to our situation. So what is unique about our situation that is not available to the folks who are using cancellation tokens in .NET, who have to generically handle all possibilities? Well, I would say that the biggest difference is that .NET is an object-oriented, object-first language. It's really an object-centric language, whereas JavaScript is not. It's a multi-paradigm language. It has objects, although I'd say that the C# and Java folks would probably say that it's not very good objects, and it has functions, although the functional folks would probably say it's not very good functions. So it's a sort of a mediocre multi-paradigm language. I love JavaScript, don't get me wrong, but it definitely has its quirks. But we do have, because it's got this functional capability, I wonder if we could take advantage of that somehow. My biggest gripe with the cancellation token approach is how the cancellation is disconnected from the transform. So what if, instead of passing in this cancellation source, what if we just had the transform return a function that can be used to cancel the transform? Now that would be really weird in something like C#. You can return functions in C#, but it's not sort of the way people work. And also, we need to return two things. Let me go ahead and factor this out. Transform async returns a transform promise. And so we're already returning something, but returning multiple values in JavaScript is super easy because we have destructuring. So we could return the transform promise and we could return a cancel function like that. And that's really interesting because now if we've done that, all we have to do is pass in the cancel function here to our timeout. We'll take it here and then we call it directly. And now there's a really direct link between this cancel function and canceling our route13.transform, because that cancel function is returned by the transform. It's obvious that it's related to that transform. Now, there are some aspects of this that I don't like. First off, it's possible that there are things that the cancellation token approach solves that I'm just not aware of. So there could be some hidden gotchas. Another thing is that now the return value is kind of implicit. We have to know what route13.client.transform returns. Here it's obvious because passing in the cancellation token is is part of the parameter list. So that's nice and obvious. So I'm not making this up. I'm honestly not sure which of these approaches is better. But I would like to try the cancel function approach and see how it works out. And then if it doesn't work out, we'll go back to the cancellation token. Uncle Scientist in the chat says, does the token approach allow you to cancel multiple requests with a single cancel call? Yes, I believe it does. The cancellation, you cancel the cancellation source, and that cancels all the tokens related to that cancellation source. And that might be an example of where it's solving something that we don't care about, because we only need to cancel one thing. Yeah, Pellet agrees. In the .NET sense, you cancel the source and all the tokens are canceled. So like I said, I'm not sure that the cancellation function is better than the cancellation token, but I really like how direct it is. So I'd like to go ahead and give it a shot. Pellet goes on to say, which seems like overkill if you only need one. Exactly. Again, what you can do, the advantage of coding a specific solution is you can often cut out the complexity of the generic solutions because you don't actually have the problems that the generic solution solves. And so you can very often come up with a better design than sort of the generically accepted design because you're cutting out all the stuff that doesn't matter. So don't assume that the generic solution, even if it's widely accepted, is best. Don't assume yours is better either, but don't assume that just because something's widely accepted it's better, because your situation is different. So that's what we're going to do. We're going to use we've used programming by intention. We've made a simpler solution specific to our situation. We've looked at it. That it's not clear that one is much better than the other, but I am going to go ahead and try the cancellation function. So let's go ahead and try that. I'll go ahead and reset back to where we were. Let me turn off this server. And let's do it. Now, as a reminder, the way that our code works is we've got our route 13 command line, which uses our route 13 client, which uses our HTTP client. And this is where the request actually lives. This is where the cancellation happens. So to implement this, we're going to have to build from the bottom up. We'll start with the HTTP client, then go to the route 13 client, and then finally hook it in at the top level. Now, Pellet says, I can see it being handy if you have a sequence of async calls, and if one fails, you want to cancel all of them. But if you only issue one at a time, it seems unnecessary. Yeah, I would agree with that, Pellet. I think the cancellation token approach makes a lot of sense if you're canceling a whole bunch of requests together. Pellet goes on to say that I need a concrete cancellation token manager factory singleton to generate and return the cancel function. Well, if we want to do enterprise OO properly, then I have to agree. But luckily for us, we don't. So let's go ahead and try this cancellation function approach. I think though, Pellet, I think you've hit on the big flaw of the cancellation function approach, which is that the cancellation token makes it really easy to cancel a bunch of stuff together. But I still like the clarity of the cancel function. So let's go ahead and try it and see how it turns out. Charlie Pancake says, cancellation tokens as a service. I'm not going to go there. So what we need to do is we're going to start out down here at the HTTP client. And let's go ahead and start programming this. Okay, again, what we're going to be doing is we need to have request.destroy show up right here. But of course, we're going to do this test driven. But before we can program this, we're going to change our signature, because right now it's returning a promise that resolves when the request is complete. But what we want to do instead is we want to return an object that has the promise and the cancel function. So let's start out by doing that. We're going to change this from request async to just request. We'll get our promise here. So this will be our response promise. And that will resolve when the response resolves, just like it does currently. But instead of awaiting that promise, we're going to return it in an object. Now this has changed the behavior of our function. It's going to cause a lot of stuff to break. Let's see that happen. Yeah, all kinds of stuff had broken. Of course, the HTTP client tests are going to break. Now, I took the liberty of wrapping this code a couple of weeks ago, so it'd be easier to do this today since we don't have a lot of time. So request async, what we want to do is await the response promise that is returned from that. So that should solve all of our HTTP client test failures, except this needs to be a request. But because we have sociable tests, we still have a whole bunch of tests failing. And this is actually a good thing. If we were using mocks, we could have changed the signature, changed our mocks, and had all of our tests pass. And then everything would be fine, except the code would fail in production. But because we have sociable tests and we're not using mocks, our Road 13 client is actually talking to our real HTTP client, and it's saying, well, hey, HTTP client's returning something I don't understand. So what we need to do is go into our Road 13 client, and we need to have it actually await the response promise as well. And that will make the Road 13 client work properly. And now all of our tests pass. So there we go. So let's get back to our HTTP client. It has now got the signature that we want, or at least it's returning an object, which we can extend. Now let's go ahead and do some more here. So we've got our tests, happy path tests, our failure path tests, nullability, which is what makes our sociable tests work. Let's go ahead and add a new block for cancellation. And what we're going to want to do here is we're going to want to say that this can cancel requests. And the way this works is we can actually make an HTTP client and make a request of that client. Like this. Now we're going to want that request to hang. And the way our HTTP client tests work, and again, if you're curious about this, you can check out the back episodes, jamesshore.com/s/LNL for Lunch and Learn. If you go down to the past episodes, it's microservice clients without mocks, part 1. But the way this works is we actually spin up a real server so that we can test that this works for real. And we can tell that server how we want it to respond. And to make things go a little faster today, I've pre-coded that server to hang if we pass in the hang true option. So what we should see here is if I await this response promise, that code, this test should now hang. And it does. So that's good. So now what we're going to want to do is we're going to want to get a cancel function out of this, and we're going to cancel the request. That of course will fail. We're not returning, and then let's await the response promise here. The cancel function is going to fail because we don't return a cancel function right now. It's going to say it's undefined or something like that. And that's what we get. Cancel function is not a function. So here we need to make a cancel function, but we have to define it out here so that we can return it. But we have to implement it inside here because this is where we have access to the request. And luckily, because JavaScript is a single-threaded system with the event loop, I know that this cancel function code here will run before we do the return, so I don't have to worry about race conditions. So this is still going to fail because we're calling the cancel function, but we're not then doing anything with it. We're still timing out. Let's go ahead and code a little bit more here. We want to assert that our response promise is going to throw an exception. And as I've mentioned in past episodes, this throws async is not part of Chai, which is the assertion library we're using. If you're curious or you want to use it, I do have it in the source code. It's a thin wrapper around Chai, and it's implemented here in assert. So let's assert that that response promise is going to throw an exception. And the reason we're going to do this is because request.destroy will cause the error event to be triggered, and when the error event is triggered, we reject the promise. So that results in an exception being thrown in here. So let's say that we're going to throw, we're going to cancel with my cancel message, and then we'll get that as our error here. Now I don't expect this to happen because we're not doing that yet. We also need to await this. So let's go ahead and make this work. We're going to just have this call request.destroy with a new error and the message. And I think that will work. And it does. So let's now deal with the case that what happens if we try to cancel again? So let's say it ignores additional requests to cancel. So it's going to be basically the same thing. Except this will be the first cancel, and this will be the second cancel. And what we're going to say is that we still get the cancellation error, but the error we get is from the first cancel. And that works just fine because that's just the way it works, but it's nice to have it documented. The other thing that I want to do here is that I actually, in my rehearsal, I didn't discover this until later, but we need the cancel function to return whether or not it did cancel or not. Because when we get to the route 13 client, we're going to need to be able to take action depending on whether or not the cancel succeeded. So let's go ahead and do that. Let's have the cancel function by default return a value, and we want that cancel value to be true. That didn't work because, well, right now it's not returning anything, but that's really easy to fix. We'll just return true here. Uncle Scientist asks, is that if there's a race between resolve and the user calling cancel? Are you talking about whether or not we should returning whether or not this succeeds or not, Uncle Scientist? Assuming you are, that's actually not what we need. I'll get into it when we get there, but it has to do with the way we make the code testable. So here we're going to say that the first cancellation succeeded, but here what I want to do is say that the second cancellation failed. Of course, that doesn't work because we're hard coding return true. So what we need to do now is we need to say that if we are not cancelable, we'll return false. And I'll set up another variable here so that, and then we'll say that after we do the cancellation, we're no longer cancelable. So that solves that. Now, what else could go wrong here? Well, or what other edge cases do we want to deal with? Obviously, we're canceling requests. We're ignoring additional requests to cancel. What if the response has already been sent? Let's say that it ignores cancellation that occurs after response has been received. So here, we're going to do something really similar, but we're not going to have the server hang this time because we're just going to wait for the promise. Let's assert, so we'll just await the promise. Response promise. And then we will cancel, and we should expect that will not have worked. Uncle Scientist says that's what they were getting at. The promise resolves and then we call cancel. Yeah, we need to be aware of what happens in that situation. And let's say that we want to make sure that this response promise does not throw. And again, this is part of my little wrapper on top of Chai. Now I can't imagine a situation where this would throw because this actually happens before we cancel, but let's just make sure there's no exceptions. So that is going to run, and we're missing a semicolon here. So we didn't get any exceptions, which is good, but we also said that the cancellation was successful. So what we need to do is come back to our code and say that after we get the end of the response, we'll say that the request is no longer cancelable. And there we go. Okay, what else do we need to do? Well, we need to be able to test this, and we're going to need to be able to make assertions about whether or not the request has been canceled. So let's say that it tracks requests that have been canceled. Or let's say that are canceled. I think that reads a little better. Now, I'm going to just steal some code that we've already written. Now, I could come up with some way of factoring this out, but I find that my tests are easier to read if I don't have too much abstraction in them. So I'm just getting cut and paste in this case. I wouldn't do that in production code, but test code, it seems to be okay. So we're going to need to make the server hang. We'll create the client. We'll track the requests. We'll make a request. I won't worry about the headers of the body. So we'll expect nothing back. Now this, okay, and then here we'll say our response promise and cancel function is equal to client.request. So we'll run the cancel function, and then we'll ignore the promise error because we don't care about it. And then we'll assert what we get back. Now, right now, I think it's just going to give us the request. So that test should pass. Except that's failing because we were using the null and we don't have that set up yet. So let's just use the real thing. Okay. So that's working, but this isn't how we want it to behave. What we want it to do is we want it to tell us when the request has been canceled. And I think the way I want to do that is we'll just repeat the same event, except we'll have the canceled option on it this way. That way, if there's multiple requests, we can distinguish between which one is canceled and which one's not. Now this, of course, is going to fail because we're not actually outputting this second event. So that's what we need to do. Let's come back to our code, and we're going to put that right here in our cancel function. But let's first factor this out into our request data. And then we can say this.emitter.emit request event request data, and we'll just use all the request data and add on a canceled true. Okay, that works great. One more thing, let's say that it doesn't track requests that are canceled, or doesn't track cancellations that occur after response. And this is just, I think, more for documentation because I'm pretty sure this is going to work. So we're not going to hang. We're going to cancel after the response. And we expect to only get the first part back. Okay, so we're just about done here. The only thing we have left to do is make sure that the null version of our HTTP client also works with the request.destroy. The reason it doesn't work right now is because the way we've implemented our nullable HTTP client, and again, if you want the details on this, go ahead and look at this microservice clients without mocks part 1 episode. But the way we've implemented this is with an embedded stub. The null runs all the same code as the real production code, except that when we get to the actual node call to use http.request, that's stubbed out. And that's stubbed out down here. But we're now making a new method call on request that we didn't have support for before. So we're going to have to make that work. So let's just add a little test down here. Let's see. This is going to be response promise and client.request. We're going to do something a lot like this, except that it's going to can cancel requests. Except we'll also get the cancel function, and we're going to run the cancel function, and then we could do whatever we want. Let's just assert. Let's assert that the promise throws. And I think this is going to fail, saying that it doesn't know what to do with the destroy. And that's exactly right. So now we come into our HTTP client and we come down to our request stub, and we can add in the destroy method. And we need this to simulate the way the real node code works. And what the real node code does is it comes around and it calls this, it triggers this error event. So that's exactly what we're going to do here. We'll say this.emit error, and then we should be getting an error object from that. So that should just work. But it didn't. What did I do wrong? Oh, right here. Yeah, I think I've done this wrong. Let's try that. Ah, there we go. Okay. That should be good then. Let's go ahead and put everything back. Yeah, I put the parameter on the wrong function. I put in the set immediate, which wasn't passing it in, instead of on the destroy. Okay, so I think that is it for our HTTP client. You can check that in. So HTTP client can be requests, can be canceled. Now that we've gotten our HTTP client working, now we need to go up the chain and make route 13 client work. Because again, our route 13 command line doesn't talk directly to the client, it talks to our route 13 client. So that's what's next. Let's go ahead and do that. So I'll close that down, and we'll open up our route 13 client tests and the production code. Now this is going to be really similar, except that we can just now use, so here's how the transform works. We call HTTP client.request, and now that's going to return a cancel function to us, and we can just use that. Before we start doing that again, though, we're going to need to change the signature. So rather than having this return the transform response, we're going to need to return an object. But this is a little more complicated because we don't have the ability right now to return a promise, because we've got an await in here, and we don't want to return a promise that resolves to an object with a promise. We want to just return the promise. So what we need to do is we need to get this await out of our code. So this is going to happen in multiple steps. First, this response promise can be put here. We can just take the response promise that we get from the HTTP client request directly, and then we can convert that into a response. So we've moved the await down one line, but we need to move it all the way off to the end. So to move it down further, what we can do is we can have this validate and parse response. We can have it actually do the await. So let's make that an async function. We'll await it here, and then we'll move the promise into validate and parse response async. Okay, but it's still too high. We need there to be no await until the very last line. So right now we have to await the response here so we can look at the transformed result. But if we take this transformed result and we move it into validate and parse response, then we can have this just be transformed and we can return transformed directly. So that's good. So we'll return parsebody.transformed here. Still good. Now let's have this be, rather than a transform value, a transform promise. And now we can return await transform promise. And we successfully moved the await down to the very bottom, which means that now, rather than returning await, we can just return an object with transform promise in it. This does not have to be a let. And that means we can take this and turn it from being async to just being a function call. Now this is going to cause all our tests to fail because we've changed the signature. We can go into our route 13 client tests, and here we'll call transform and await the transform promise that comes out. But again, we have sociable tests, so our command line code is also going to fail because it actually doesn't work anymore. So we'll go into our command line code, and here we will race not transform async, but transform.transform promise. And we are still looking for a transform async somewhere. Here it is. No, that one's correct. Where's our missing transform async? 135. Right here. This response promise should be a transform promise. Like that. Okay, there we go. I really like sociable tests for when you're doing this sort of bigger structural refactoring because it catches everything. You don't have to go through, you don't have to update a lot of mocks, and your tests will fail until your real production code works. And it's just really nice. And this is, I think, the biggest benefit to sociable tests is that it really supports the kind of structural refactorings that we're doing here, which you will want to do on occasion. Okay, so now that we've got the tests working, we can go through and implement the cancellation. Again, we've got the happy path block, we've got some failure paths, we have some nullability. So let's go ahead and describe cancellation. We're going to say it can cancel requests, just like before. And well, we're going to want to make the route 13 client, and let's also look at our HTTP requests because we want to see that we've actually canceled them. And we've got a little helper method to do this for us. And we're going to want the client to hang. Under the covers, what create client is doing is it's using HTTP client.create null. So then we've got once we have our route 13 client, we can get a transform promise out of it and a cancel function. And we can make our transform call, and we'll pass in the port and the text. And then if we await the transform promise, I think we'll see this hang. Let's just see that that works. Okay, I was expecting that to hang, but it didn't. that's probably because we're not actually making a real network call, so we're not causing Node to hang in any way. I'm not sure, but let's keep on going. If we call cancel function, this should now fail because cancel function doesn't equal anything. Yeah, cancel function is not a function. But here on a response promise, we can just get the cancel function from our HTTP client request, and then we can return that directly, like that. And we're getting an error, which we'll come back to. But let's assert that our transform promise does throw an exception. And we're not passing any error message, so it's just going to give us an empty error string, I think. Yeah. Okay. But I also want to assert that we've actually seen the request cancellation come through. So let's look at all of our requests, all of our HTTP requests. And to do that, I'm going to actually steal some code from up here. So there's the request that we're actually making. This is going to be port 999, and the text is text to transform. Okay, there we go. There's our request, and there's the same request again with the cancel flag. So that's good. That's exactly what we expected. So let me just go ahead and add that here. So we've asserted that the cancellation is actually happening. I don't know if that was really necessary because we did get the error we were expecting back out, but it's nice just for, again, for documentation purposes. Okay, now let's look at the error we're getting out of it. Right now it's an empty string. I don't want the Route 13 client to take a parameter with an error message. Instead, what I want to do is what we do with all of our other Route 13 errors, which is that we present a really nice error message explaining exactly what happened. And this is so that if it shows up in the log, it's super easy to troubleshoot. So I want to assert that we're going to get the same thing out of our cancel function. We're going to get something along the lines of Route 13 service request canceled, host 999, endpoint Route 13 transform, and then the status headers and bodies are what come from the server, so we're not going to have any of that. So that, I think, is what we're looking for. And of course, that's not going to happen just yet. Our actual is an empty string. So what we need to do is we need to have this cancel function actually cancel with the error that we want. And to do that, what we're going to need to do is we're going to need to wrap it up. So this will be the HTTP cancel function. And our cancel function will actually be another function that turns around and calls the HTTP cancel function with the specific error message that we want. And there we go. So now we have this canceling, and we have it canceling with a really nice error message. And by the way, I don't know, if you think about the cancellation token approach, I have no idea how you would make this work with the cancellation token approach. Because I guess the Route 13 client would have to make a new cancellation source and talk to the underlying HTTP. Because the cancellation token source doesn't pass parameters through, I don't think, and because it's sort of indirect, I'm not sure you could do this as easily with the cancellation token design as you can with just the cancellation function. But I don't know, it'd be interesting to try, that's for sure. Let's see, now in addition to canceling requests, we also want to track requests that are canceled so it can be tested. So let's do that. It's going to start out very similarly. Except now we don't need all the HTTP requests. And we do need to have the request tracked. So we'll look for HTTP client or route 13 client dot track requests. Then we'll make the request and we'll cancel. And let's assert that the requests equal what we want, which in this case is going to be, let's just look at how this has been done in the past. Port 999 and text, whatever my text is. My text. So I think this is how it works now. So this should pass. We don't actually have a memory leak in our code. There's a memory leak in the watch script, which is why it does that. Let's see. So we don't have an await expression. Right. We need to ignore the promise. We expect the transform promise to throw an error, and we need to just ignore that. Okay, so that's working, but that's not the behavior we want. We actually want this to give us another request in our array here that has a canceled parameter. So let's do that. That, of course, is failing because we're not doing it that way, but here we can just omit that event again. So let's go ahead and pull this out into our request data, and then we'll omit it when we do the cancellation. But let's actually do that down here after we do the cancellation. Oh, and of course, we need to actually say that it's canceled. There we go. But what about if the request has been canceled after the response is received? Well, let's say that it doesn't track requests, cancellations that happen after response received. So it's going to be really similar, except we're not going to hang, and we'll await our transform promise right away, which should just resolve. Then we'll cancel, and we'll assert that we don't get the canceled request. Okay, it's failing because we are getting it, and this is where the need for HTTP cancel function to return a canceled value comes in. And I actually, in my rehearsal, I discovered this later, but I thought for the purposes of my demonstration today, it'd be easier to understand if I did it all at once. So that's why we return the canceled value from HTTP cancel function, and then we can check it right here. If it was canceled, then we'll omit the event. And there we go. I think that's it. We don't need to test the null because we didn't do anything with the null, and we don't have an embedded stub in the route 13 client. So that should do it. Let's go ahead and check that in. So all we have left now, and we might run a little bit long, but we're doing pretty well. We've done our HTTP client. We've done our route 13 client. Now the whole chain is cancelable. Now what we need to do is we need to make our route 13 command line actually use that code. So let's go ahead and do that. We'll come into our command line test and our command line code. In the test, right here we have this outputs an error when route 13 service times out. let's say that it times out route 13 service when service responds too slowly. We're going to do the same thing. We're going to advance the clock. We're going to assert that the promise resolves, so we do finish the thing. We're going to assert that we get the service failure, but I also want to assert that we see the cancellation request. So we're going to get our requests here. I think it might be called route 13 requests. And it's going to be the same as what we're doing up here. We're going to expect to see the valid port and valid text. That's going to be the first request. And then the second request is going to be the same thing again, except now it's going to say that the request has been canceled. So this is how we expect the code to work, but that's not how it works right now. So this should fail. Should fail for the right reason. And it is failing, and it's not seeing that cancellation. So now we can go into our route 13 command line. And here, we'll take this, we'll factor it out, and say that our transform promise is returned to us from route 13 client.transform. This should behave the exact same way. And then that will also give us the cancel function. And we can pass that cancel function into our timeout. And our timeout can call it after the clock times out. And if the response has already come in, we already know that the cancel is ignored if the response has already come in. So this should just work. So that's it. I think that really is everything. Let's see if it really does work. I'll start up the server again, and I'll run the client. And, well, that time it actually worked. That time it worked. We'll get a delay out of this puppy somehow. There we go. There's our delay. 3, 2, 1, cancel, and our command exited, or our command line exited. So we actually did see it work. So there you go. Works the first time. Pretty much every time. With the sociable tests, if the test passed, generally speaking, your code will work unless you've made a different kind of error. Test-driven development's really good at catching programming errors, not so good at catching misunderstandings about how if I had misunderstood how Node works entirely, or if I had a requirements error or something like that, test-driven development wouldn't help with that. But it's really good at making sure the code works exactly the way that you think it should, which in this case was the correct way to work. So that is request cancellations. What we've done here, just to remind you, is we reviewed generic approaches to the problem and found the cancellation token approach. And then we used programming by intention to make a simpler solution specific to our situation. And that simpler solution was the cancel function. And we built that into the HTTP client, built it into our route 13 client, and then up in our route 13 command line code that's actually using it, it came out just really nicely. Charlie Pancake says, one of these days it's not going to work the first time. It's true. It doesn't always work the first time, but it almost always works the first time. Okay, I will take additional questions, and I have some announcements in just a moment. Before that, though, so go ahead and toss them in the chat if you have any comments about what you think. I'd love to hear what you think about this approach versus the cancellation token approach. I honestly have not used this cancellation function approach before. I really like it. I like how well it works. Again, if you look at the way the route 13 client works, this if canceled, then emit, I have no idea how you do that with a cancellation token approach. I think it would get really messy. I could be wrong about that. So, and I do like how direct the cancel function is. It's really obvious that we're getting the cancel function from the function call and then we're using it. So that is really nice. But it is not the standard sort of accepted approach, so there's probably some flaws. I'd love to hear what your thoughts are about which one is better. Any other questions and comments, go ahead and put them in the chat. But because this is our penultimate episode, and this actually wraps up the entire arc of client-server code that we've been writing here, I want to go one step further. And I want you to notice when the service doesn't time out, if I can get that to happen, you'll notice that it's still hanging for 5 seconds. And that's because to do that timeout, we're setting a timer, and then we're not ever stopping that timer if the code was successful. And I don't think this is interesting enough to do a whole nother episode. So what I did was off camera, I built what we would need to make this work. And what we need to make this work is a new method on our clock abstraction that did a timeout and then canceled the timeout if the promise resolves. So let's show you what that looks like. And I've got that method already written. I'm just going to use it. First, let me check in what we've got. The route 13 command line cancels requests that have timed out. So what we want to do here is in our route 13 service, after we've checked the results, I'm going to tell our code I'm going to tell our clock, which I'll get right here, to advance our null time past until all the timers have finished. And because in this case, this is the happy path case, because we're supposed to get a response right away, I'm going to expect that the current time should be 0. No time should have passed. But that's not what's going to actually happen. It's going to say that 5 seconds have passed because that's how long it takes the timer to resolve. So in our command line, instead of doing the promise.wait and the clock.wait async ourselves, instead, I'm going to use the clock abstraction I built off camera. And that clock abstraction is timeout async. So we're going to wait timeout async. We'll give it the time to wait. We'll give it the promise to wait for. And then we'll give it something to do if the timeout doesn't happen, if the code does timeout. In this case, what we're going to do is we're going to call timeout with our cancel function. And we no longer need the clock down here, so we don't need this to be async, so we can do that. And that should now work. Except response is not defined on line 39. Oh, and yeah, this is going to return the response. So it's under the covers, it's doing something very similar to the promise.race, except it's dealing with clock timeouts and stuff like that. So it will return the result from either the transform promise or the cancellation function, whichever happens first. So there we go. It works, or the test passed, so should work the first time. Let's find out. We're going to run this, and there we go. Works the first time, pretty much every time. And that really is the end of the episode for today. Let's see if we can get that timeout to work as well. There we go. 3, 2, 1, timeout. There we go. So everything's working. That is the complete result. So I'll go ahead and check that in. Route 13 CLI doesn't wait for timeout when a network call is successful. Okay, again, if you have any comments, I'd love to hear them. So a couple of announcements first, though. Next week's episode is our last episode. That is going to be September 29th at the same time. That's going to be noon Pacific. And what we're going to be doing, you've been noticing we've been doing a lot of stuff with client-server code, doing a lot of microservice stuff, but you'll also notice that there's a lot of complexity to this code, a lot of error handling. Wouldn't it be nice if we could get the benefits of microservice architecture without all the overhead? And that is what we're going to be covering next week. It is our final episode. Should be a lot of fun. And I hope you will join me. So that is that. Also want to remind you that if you liked what you saw today, I'm very happy to bring this sort of training to your company. Whenever I work with a company privately, then of course it's done in your language using your frameworks and libraries, and often actually doing it, working in your actual code base so you can transfer the ideas. I work in JavaScript, TypeScript, front end, back end, C#, and Java, and I would love to hear from you. You can reach me, jshore@jamesshore.com, or find me online at jamesshore.com. And doesn't look like there's any additional comments. Thank you all for watching. So remember, next episode is September 29th, and that will be our last episode. I'll have the code uploaded for you in just a moment. And other than that, I'll see you next week. Thanks very much for watching. See y'all next time.